right, so let's go back in time for a moment, back to the days of elementary school, to when we were doing long division. Because we're going to use all these same skills to help us divide today. The division that we talk about today is going to be just what we do today. It's going to be our skill for today. However, in the grand scheme of things, it's eventually going to help us solve equations. So it's a skill we need to pick up that we're going to use further down the road. Can we all see that too small? Or it's good? Okay. All right, so here we go. Can I divide 5 into 1?
No.
Bummer. Can I divide 5 into 13? Yes. How many times does 5 go into 13? 2. So where do I put the 2? Do you remember? Yeah, above the 3, right? Placement's important here. And so then I say, okay, 2 times 5 is actually just 10, right? It wasn't quite 13. Do you remember what I do after that? Subtract, yes. 13 minus 10 is 3. Okay, do you remember what happens next? Not the whole rest of it, but just, yeah, one at a time. So let's drop the 4 down. Okay, how many times does 5 go into 34? 6. So the 6 goes here. 6 times 5 is 30. Subtract, and I get what? 4. Then what do I do? Bring down the 6. Okay, we'll pretend we aren't running low on space, but we are. How many times does 5 go into 46? 9. 9 times 5 is actually what? 45. I subtract and I get 1. And then what do I do? Bring down the 2. How many times does 5 go into 12? 2. 2 times 5 is 10. So if I subtract, I get 2, and then I bring down the 3. And then how many times does 5 go into 23? 4. And so then I get 20. And what is that 3 that's left over called? Yes. So we would say my remainder is 3. Is that kind of coming back a little bit? A little bit, a little bit? Okay. So that's what we're going to be doing today. That same process, that same set of steps, except instead of just numbers, we're also going to throw some letters in there too, right? So here we go. Whatever you're dividing by is the thing that goes out front. So I'm going to move over here so I have more space because I already have written over a lot of it. So the 3a squared is going to go out front. So whatever you're dividing in is the thing that goes here. Then you're going to take this and you're going to put it under the root. Now, before you put it under, you need to make sure that it's in standard form. Is this in standard form?
Yes.
Then you need to think about one more thing. And you need to think about if you're missing any terms. So if we're starting with a to the 5th, I need an a to the 4th term, I need an a to the 3rd, I need an a to the 2nd, I need an a to the 1st, and I need a plain old number. So if I start with a to the 5th, I need one of everything from there on down to a constant term. So, do you agree that I only have a to the 5th, and a to the 4th, and a to the 3rd? Okay. So if you are missing any terms, you have to fill them in. So I have 0a squareds, I have 0a, and then I have 0. So we might not get to a point where we have to factor this in too much. Sometimes you do, sometimes you don't. But again, we've got to at least have it there so we know that's what would be there if we continued it on. So when you put this under here, there are 2 rules. Rule number 1, it has to be in standard form. Rule number 2 is if you're missing any terms, you have to put in placeholders. So these things are my placeholders for the terms that we're missing. Okay, so maybe we write a note about that up here somewhere. So we need to make sure, I'm going to go sideways here. We need to make sure we are in standard form. So that's step one, make sure it's standard form. And we need placeholders for missing terms. Okay, so those are the two things that we've got to have before we get started. So standard form is thing number one. Placeholders for missing terms is thing number two. Okay. All right. So we're going to play the same game that we did a minute ago, and we're going to think of things that would multiply us to get to whatever we have under the root, right? Because here we were multiplying to get as close as we could to 13. Agree? So 5 times 2, we were trying to get as close as we could to 13. So here I need to pick something so that when I multiply, I either get exactly this thing or as close as I can to it. So 3 times what would give me negative 12? Negative 4. And then a squared times what would get me, bless you, a to the 5th? A to the 3rd. Okay, so step back for a second because that's kind of a lot to digest just in and of itself. So 3 times negative 4, is that negative 12? Yes. And then a squared times a to the 3rd is a to the 5th. So does it give me exactly that term? Yeah. Okay, that's what we wanted to have happen. And then, once I got that, what did I do? Subtracted. So if I subtract, this becomes minus a negative, so it's really plus a positive. And what happens? It cancels, so I just have 0. Okay, think back to the division. What did we do next? Yeah, we bring down the next term. So do you see how it's the same steps, it's trickier. All right, so I'm going to erase this part because it's going to mess with me. I'm going to erase with the 0 plus, okay? So we know there'd be a 0 there. It's just going to mess with my head a little bit, so I'm going to make it go away. Because adding 0, does that do anything? No. Okay, here we go. 3 times what's going to get me to 30? 10. And then I heard somebody say a squared. Do we agree a squared times a squared, will that get me to a to the 4th? Yes. So 10 times 3 is 30. A squared times a squared is a to the 4th. And then we subtract. Or you can think of it as switching the sign. So either think of it as subtraction or switching the sign, whatever works best. What happens? They cancel again, right? Kind of like they did here. So then what do? Bring down the next thing, which is a positive 21a cubed. You're done? Okay. All right. 3 times what is 21? 7. How many more a's do I need? 1 more a to get up to a cubed. All right, now 7 times 3, 21. A times a squared is a cubed. And then I subtract, and I end up with 0. I end up with nothing again. Now, do you see how we put all these extra bonus terms over here? I don't need them if my remainder is 0. Had it been something else, 5, 6a, anything, then I would have had to continue going and dropping stuff down. But because we ended up with 0 and there's truly nothing left, how many times does this go into nothing? 0 times. So this would be our final answer. So if I do long division, my final answer is negative 4a cubed plus 10a squared plus 7a. And this would be my final thing. Now, as a way to check your work, you could take this and multiply it by this thing, and you should get this value that we started with. So that would be a way to check your work. So to take this, multiply it back by this, and make sure you would get back to where you started. All right, sometimes though, we get trickier problems than this. Do you see how there was just one term right here and that kind of made our lives easy? Okay. Uh-oh, what if there's more than one term? Okay, here we go. We can still do this. X minus 3 is the thing that's getting divided in, so it goes out front. Here's my division. And then this is the thing that goes under my division symbol. So I'm here. All right, so what do you do if you have more than one term? Okay, we're still going to play a very similar game to the game we were playing a minute ago. You're only going to look at the first term, though. And you're going to try to get it to match this first term. So only look at the first thing. Don't worry about the minus 3 for right now. X times what will get you to x squared? X. Okay, so we only worry about the first term here. We don't worry about the second term. It'll still factor in just a second, but when we're trying to figure out what multiplies, we only look at the first term. Okay, so now I'm going to take this and I'm going to multiply it. X times x is what? X squared. I also have to multiply it to the negative 3. What's x times negative 3? Negative 3x. So this gets multiplied to both things. Now, instead of thinking of it as subtraction, I like to think of it as switching the signs. So I'm going to switch the signs. So this step, again, I think of as switching the signs. Because otherwise, if we think of it as subtraction, oftentimes people forget to subtract the next term. So I call it switching the signs because then it's easier to remember to just change everything. Okay, so we're not just changing the front sign, we're changing all the signs. All right, what is x squared minus x squared? 0, it's gone. Negative x plus 3x. 2x. Okay, so after we subtracted, what was our next step? Bring down the next thing, which is a minus 6. Again, we only care about the first term in both. We're going to ignore the second term. X times what would get you to 2x? What would you need to multiply x by?
2.
Just 2, right? And a positive 2? Okay, so I'm going to put plus 2. And now I need to distribute that. So x times 2 is 2x. X times negative 3 is negative 6. And I'm going to switch my signs. So again, here's another sign switch. Sign switch. All right, what happens?
Cancels.
It cancels, so my answer is just this. So if you were to take x plus 2 and multiply by x minus 3, would you get back to where you started with? X squared, negative 3x, positive 2x, yep, that gives me negative 1x. Negative 3 times 2, yep, that gives me negative 6. So do you see how you can go back and check your work? Okay. Let's keep going. We've got some more practice problems. I don't know if we'll always, or if we're going to do all of them, but we're going to do a couple more. There is another method for division, and we're going to talk about that tomorrow. So there's a second method. Do you remember how it kind of works when there are two methods to do something? I do the easier one when? The second day, because if I show you the first day,
You will never do it.
yes. So this is the harder of the two, okay? That's the good news. All right, look at the next one. The next one is trying to throw you off. This -1 is telling you it's in the denominator. This -1 is telling you it's in the numerator. So what do you do? You If it's in the denominator, that means it's getting divided in. So x plus 7 is getting divided into negative 6x squared plus 5x minus 10. And yes, we're going to come across problems that have a remainder. We haven't yet, but we're headed in that direction, okay? So that's how you're going to set this one up for starters. Notice that I haven't been mentioning it, but is this in standard form? Am I missing any terms? No. So that's something that's always running through the back of my head. It's like, you know, a program that's open on your phone that's like running in the background, right? That's always something that's running in the back of my head. So make sure you're considering that every single time. Is it in standard form? Am I missing a term? What do we do with what? The negative one we took care of, because this is just saying that this is going to go down here like this. The negative one is making it go to the denominator, so it's really just getting divided in. So remember, a fraction is the same as this thing getting divided into this thing. So they're just giving it to us in a different format and trying to throw us off, but we're not going to let them. Yes. Okay. So again, we only mess with the first number. So we're ignoring the 7, we're ignoring all this stuff. We're just looking at the x and the negative 6x squared for starters. All right, so basically this is a 1x. What can I multiply 1 by to get to negative 6? Negative 6. All right. And then what do I need to get to x squared? X. So I'm going to take this and I'm going to distribute it to both things. Negative 6 times x is what? Or sorry, negative 6x times x. Negative 6x squared. Negative 6x times 7. Yeah, negative 42x. Let's draw our line underneath. And then remember, I like to think of it as a sign switch, because otherwise I forget to distribute the negative. And if I've been doing math for a million years and I forget to do it, my guess is you probably will too. Or maybe you're a step ahead of me. I don't know. I spilled my coffee on my computer this morning, so that's where I live. So maybe you're a step ahead of me and you would have been fine. That's fair. Okay. Sign switch. What happens to my 6x squareds? They cancel. 5x plus 42 more x's. How many x's do I have now? 47x. And then just following our rules of long division, what do I do next? Yeah, bring down the negative 10. Oops, I almost wrote a plus. I've got a minus 10. So we're definitely going to have a remainder with this one. And we'll talk about how to write that, because we write it actually a little bit differently. Okay, so we play the same game again of we only care about the first two things. We'll deal with the other stuff later. X times what will get you to 47x? Okay, so I need 47. 47 times x, thank you, is 47x. And then I'm going to do 47 times 7, which I have no idea what that is off the top of my head. I was going to say, I know it ends in 9. That's all I can tell you. 329. Okay. Now, I need to switch both my signs. So negative and a negative. What happens to my 47 x's? They cancel. Negative 10 minus 329 more. What's that going to be? Negative 339. So normally we would come back up here, right? And we'd say remainder negative 339. Okay, let me show you how we write out our final answer. So I got negative 6x plus 47. Agreed? Oops. Then the way that we write it, I always put a plus here. And then this last thing is going to be a fraction. You always take your remainder. So in this case, my remainder was negative 339. And you put it over your divisor, which is the thing you divided in. And just like the last couple, although this one would be trickier. If I took this whole mess and I multiplied it by x plus 7, I should get back what I started with. So you take everything you have and you add on your remainder. So your remainder is whatever you had as the remainder, the number, divided by the thing you were dividing it. Okay, let's try another one. You ready? The more you practice, the better. I may have lied. We may actually do all of these. Sorry. False alarm. I feel like the more practice, though, the better. Like, I'd rather send you off and feel like, got this. Okay, x plus 3 is getting divided in. So x plus 3 goes out front, and it's dividing into. Remember I said I have that program running in the back of my head?
Yeah.
I see something that's in standard form. However, there's something missing. What's missing? The x term. So I'm going to write 3x cubed plus 9x squared plus 0x for the placeholder minus 14. So again, if any of the terms are missing, you need a placeholder to represent that. Okay, so again, we're only going to care about the first things. X times what gets me to 3x cubed? Squared. Yes, bless you, by the way. I'm going to distribute that to both things. So again, we've got those two terms, so now we're multiplying it to both of them. 3x squared times x is what? 3x cubed. 3x squared times 3. 9x squared. Ooh, so that was kind of nice because watch what's going to happen. Switch your signs. What happens? They both cancel. Good news. Now, if I bring this down, let's bring down both of them and look at what we've got left over at this point. I've got 0x minus 14. So do you agree if it's 0x, thank you. Huh? Yes. Do you agree that I really just have a negative 14 left over because the 0x does nothing for me? Okay, so I'm going to get rid of the 0x. And I guess I should have mentioned this last time, but I didn't. Do you see how I get to a point where, like, there's nothing I can multiply x by to make it negative 14? Yeah. Right? Like, I can't, like, backtrack and make the x disappear. Like, I'm not a magician. So once you get to a point where you can't, like, you have an x, and then, but this doesn't, there's nothing more you can do. So this is going to be my remainder. So my remainder is negative 14. So we only had one thing this time. So 3x squared was the one thing, plus I'm going to add on my remainder. Remember, my remainder is written as a fraction. This goes in the bottom. Whatever you were dividing in goes in the bottom. And the thing that was your remainder goes up top. So this would be my final answer. And again, if I took this times this, I should get back to this. All right, let's do one more. Ooh, is the next one in standard form? No, and also I'm missing a term, right? So I've got a couple things I need to take care of. All right, I've got y minus 3 dividing in. Under my division sign, I'm going to move the 2y cubed first. Then I'm going to put the minus y squared second. Then I'm going to put my placeholder for 0y next. And then the 25 last. So notice that I put it in standard form, and I filled in any of the blanks. Now, so far when we filled in the blanks, it didn't do much for us, right? Like, we haven't needed to use it much. Sometimes you really do. So we'll see if this case means that we need to use it more. All right, look at just the first thing, right? We care most about the first thing. What would I need to multiply y by to get to 2y cubed? 2y squared. Okay, do we agree with that? 2y squared times y? That would give me back 2y cubed. All right, now we need to multiply it, though, also to the negative 3. 2y squared times negative 3 is what? Negative 6y squared. Okay, switch your signs. Switch, switch. Again, the sign switch is the way that I've always thought about it because it just works better so you don't miss a sign. What happens to the y cubes? Cancel. If I have 6y squareds and I take away 1, how many do I have left? 5y squareds. I'm going to bring down the next thing, which is 0y. But I'm actually going to need that as a placeholder this time, so you'll see what happens here. So we actually need the 0y to stay put. So far it hasn't been useful. This is going to be a time where it's actually useful. Okay, we care about this. The first thing. Y times what would get me to 5y squared? 5y. 5y times y, yep, 5y squared. 5y times negative 3 is what? Negative 15y. Switch your signs. What happens to the y squared terms? They cancel out. 0 plus 15 gives me 15y. So do you see how the 0 kind of helped us there? Like we needed that as a guide. Like there was nothing there, we're adding 15 to it. And now our last step is to bring down the 25. Y times what would get me to 15y? 15. Okay, so let's distribute it. 15 times y is 15 times negative 3. Yeah, negative 45. And then we need to switch our signs. So what happens to the y terms? They cancel. 25 and 45 gives me 70. Now, remember, I can't do magic, so I can't make the y disappear. Is there any way to do anything more? No, we're done. So we've got a remainder of 70. So let's practice writing that final answer with our remainder. So 2y squared plus 5y plus 15 plus, here's my fraction, 70 was the remainder over what I divided in, which was y minus 3. What do we think? Whoa. It's a lot. Okay, let's check and I'll tell you.